Assalamualaikum to the Dr. Muhammad Azlisha and Dr. Fakurazi. My name is Najlaa Binti Bakar and my group's members Hanna Fatihah Binti Ruzahan and Natasya Binti Zukeri. Our topic is IoT Smart Head Kits Obstacle Vehicle, which is IoT Smart Blind Stick. Let's move to the extract. Pet and the blind pupil are suffering a lot because there are numerous obstacles that blind pupils must overcome in order to reach their destination, as well as dangerous risks that blind pupils must face. IoT Smart Blind Stick is great for blind people to avoid uncomfortable working experience. This paper proposes a low-cost IoT Smart Blind Stick based on cutting-edge technology as well as an innovative implementation for an efficient interface for a blind stick. The system is made up of an electronic ultrasonic sensor that is attached to the user's stick. While the user moves the stick forward, the ultrasonic sensor with ESP32 attached to the stick attempts to detect any obstacle in the path. If the sensor detects an obstacle, the recipient output is triggered. This stick acknowledges in front of the individual and responds to the blind pupil via sound. This allows the individual to walk without fear. This device will be easiest alternative for overcoming the difficulties of the visually impaired individual every day in various aspects in order to provide pupils with flexible and safe movement. This paper has proposed an ultrasonic stick for impaired and blind pupils to achieve personal independence for in this technology-driven world, so that they can move from one place to another place easily and safely. IoT Smart Blind Stick is being designed and developed that detect obstacles in blind path using ultrasonic sensor. Problem statement: can't easily recognize obstacle or stare while using normal blind stick. The blind traveler should depend on any other guide like blind cane, pupil information, trained dog, and others. About the 90% of the world visually impaired live in developing countries. No safety feature on the normal blind stick. Next, for our objective, design an assistive technology for visually impaired pupils that can detect obstacles easily. Second, to help blind pupils to walk with complete relief and self-dependency. The circuit diagram. Firstly, this project introduced an innovative blind stick that allows visually challenged pupils to use advanced technology to navigate with ease. Our proposed project initially used ultrasonic sensor to detect more obstacles using ultrasonic wave. The sensor transfers the data to the ESP32 while detecting obstacle. Then the ESP32 processes the data and determine whether the obstacle is near enough. If the barrier is not closing the circuit, nothing will happen. If the obstacle is near, the ESP32 sends a beep sound at buzzer. The circuit diagram shows the VCC ultrasonic sensor attached to the 5-volt ESP32. The trigger and echo sensor attached to the ESP32 digital pin 10 and 9. The GND sensor and GND buzzer attached to the ESP32 ground, which is connect IO pin of buzzer to the 28 digital pin of ESP32. Next, for the flowchart, which is the operational flow of the system for the ultrasonic sensor. Start with the ultrasonic detect obstacle within distant range flag in the program. Then when the data on the sensor Arduino will execute its code and the buzzer will be active to provide user the information, which is for trains. The range distance is about less than 90 cm and 120 cm. This distance for object on path. The range distance about less than 150 cm and 200 cm. And for hanging object is about less than 140 cm and 180 cm. Next, when the user near the obstacle, the data from Arduino will transmit to Arduino Mega via Bluetooth, which is distant train is about less than 90 cm. Object on path is about less than 150 cm and hanging object is about less than 140 cm. Lastly, from the data stored, an audio will notify the user according to the which obstacle is detected. Next, for coding and video demonstration. For coding, start with the define keying print for disable print and save space. Also for command chart, SSID are used for connecting with hotspot to link with keying the dashboard. Continue for command which is defined trigger pin 26 are used for ESP32 GIOP26 connect to ultrasonic sensor trigger pin. Same with command define echo pin 25 are used for ESP32 GIOP25 connect to ultrasonic sensor echo pin. The command for define buzzer pin 18 are used for ESP32 pin GIOP18 connect to piezo buzzer pin. Then the command define distance threshold are used which is the distance is set at 50 cm. Continue part delay command which is 0.017 second. Move to the command digital write which is buzzer pin height is produce a sound when the distance is detected at 50 cm, and command digital write which is buzzer pin low is the buzzer is off. Figure shows the distance serial monitor before detect obstacle. Let's move to result. Figure 2 shows the result before detect obstacle output in Cayenne dashboard, which is 251.18 cm. Figure 3 and 4 show the result after detect obstacle output in Cayenne dashboard, which is 8.68 cm and 49.44 cm respectively. Figure 4 shows the result for distance after detect obstacle output in serial monitor. Let's move to discussion. A buzzer will produce a sound when it detects an obstacle, which is the distance is set at 50 cm. The order uses an Arduino 2 ultrasonic sensor, a moisture sensor, 3 LED, 3 buzzer, and 3 vibration motor in the prototype design. It recognizes barrier, pound, and hold. Since all sensors must accurate, detect value when the stick is positioned at 90 degree angle to the ground. The 4-leg stick is also required. The suggested technique measures soil moisture using a moisture sensor. Alternately, is disable dam. The suggested technique measures soil moisture using a moisture sensor. The document also describes the measurement of the soil moisture, hole and obstruction, and the equipment. This project is split into two pieces for the smart blind stick, a slave box and the master box. The slave has three sensors that can identify trains, obstacles in the way, and anything dangling below the head. It also has initial output as one. This smart stick for the blind may also convey the user locations and a brief message to the cab. Lastly, for the conclusion, finally, the blind walking stick was transformed into a product for guiding the blind pupil. The purpose is to solve the challenge that blind pupils experience on a daily basis. This program is also taking precautions to ensure their safety. The primary goal of the research is to create a prototype in the form of audio message that can detect items or impediments in front of a user and alert them. This program encourages mobility and improves health and among people with impairment who are blind. The second purpose is achieved by completing the design with an ultrasonic sensor and a voice module to examine the nature of the smart blind handle. This is project for an automated system. Allow disabled folks to move around freely. The program will seek to make it easy for our country blind citizens to travel anywhere they want. This initiative is being undertaken to assist the blind man in traveling extremely successfully in France. This system offers a low-cost, dependable, compact, low-power consumption, and robust navigation solution with a notable quick response time. Despite the fact that the device has sensor and the other component is lightweight, wireless networking between system components can improve other elements of this gadget, such as improving the range of the ultrasonic sensor and introducing a technique to evaluate the speed of refreshing objects. When building such an effective solution, we prioritize visually impaired and blind persons in all poor countries.